Lesson 2-2, solving one-step equations. Essential question. How do you solve a one-step multiplication or division equation? All right, so we're going to jump right into our first example here. Solve 3x equals 12. So we need to isolate the variable, meaning we need to get x by itself. So I have to do the opposite operation in order to be able to do that. The 3 and the x are right next to each other, so that means they're being multiplied by each other. So the opposite of multiplication is division. So that means I need to divide both sides by that 3. 3 divided by 3 is 1. So sometimes I'll cross it off, sometimes I'll write the 1 on the first example, but you really don't need the 1 there. So 3 divided by 3 gave me the 1, and then I bring down my x. 12 divided by 3 is 4. So 1x equals 4, or the correct way to write it is without the 1 there, so it's just x equals 4. Then if I wanted to, I could go back and take that 4 and plug it into my original equation. So 3 times x, or 3 times 4, equals 12. 3 times 4 is 12. 12 equals 12, so that is correct. (25) equals negative 5x. Negative 25 equals. Train tracks. This time my variable is on the right-hand side of my equation instead of the left, but I'm still going to take the same steps. This negative 5 and the x are being multiplied, so in order to get rid of the negative 5 there and get the x by itself, I need to get rid of the negative 5. The opposite of multiplying is dividing. So again, I'm going to divide both sides by negative 5. Negative 5 divided by negative 5 just makes 1. So I'm just going to write the x there. Negative 25 divided by negative 5. Remember that a negative divided by a negative makes a positive. So I end up with positive 5 for my answer. So x equals positive 5. If you have troubles remembering your multiplication and division rules for positives and negatives, it can sometimes help you to make a chart. So remember a positive, I'm going to put the 3 options here. So if you have 2 positives that are being multiplied or divided, a positive and a negative being multiplied or divided, or 2 negatives being multiplied or divided, here are the answers you'll end up with. So 2 positives make a positive and a negative makes a negative, and 2 negatives make a positive. So if I go back over here to where I did negative 25 divided by negative 5, that would be on this row right here, a negative and a negative make a positive. So that's how I got positive 5. All right, and then lastly, I have 4x equals negative 28. Divide both sides by 4. With x equals negative 28 divided by 4. Again, I can go back up to my chart. This time I have 1 negative and 1 positive, so I'd use that middle row. A negative and a positive make a negative, so negative 7. Now we've got problems that look like division or fractions. So x over 3 equals negative 6. So now on this one, since it's x divided by 3, I'm going to do the opposite of dividing, which is multiplying. So I'm going to put times 3 over here and times 3 over here. You could also think of it as you're timesing it by the reciprocal. Because if you put a 1 next to this x, you're timesing both sides by 3 over 1, which is, again, the same as just 3. So if you have 3 times 1 over 3, you'd end up with 3 over 3, which is just 1. Bring down the x. Negative 6 times 3 is negative 18. And then again, we really don't need that 1 in there, so you can just write x equals negative 18. If I went back and checked my answer, if I changed this to a negative 18, negative 18 divided by 3 is negative 6, so that is correct. All right, second example. X over negative 5 equals 10. So the opposite of dividing is multiplying, so I'll multiply both sides by negative 5. So this negative 5 and this negative 5 make 1, or they cancel. So then I've got x equals 10 times negative 5 is negative 50. So x equals negative 50 is my answer. X divided by 7 equals negative 2. Divided by 7, opposite of dividing is multiplying, so times both sides by 7. These 7s will cancel, and I've got x equals negative 2 times 7, which is negative 14. You can check your answer on every single one of these problems, and you'll notice I only checked the first one on both slides. But you can plug your answer back in for x in the original problem on every single one to make sure you got it right. And the last set of examples. Now you'll notice this is a little bit different because we have a number next to the variable in our fraction. So rather than just x over 3 or 1x over 3, I have 2x over 3. But like on the last one, you're timesing by the reciprocal. The last two slides, the last slide, it just happened to always be 1 over the number. So then when you times it by the reciprocal, it was that number over 1. So, but really, we were timesing this by the reciprocal, 3 over 1. This by the reciprocal, negative 5 over 1. This one by the reciprocal, 7 over 1. So now if we times by the reciprocal, our reciprocal, instead of 3 over 1, is 3 over 2. Whatever you do to one side, you have to do to the other. So now if you're multiplying fractions, the way that works is you multiply across. So 3 times 2 is 6. 2 times 3 is 6. 6 over 6 is 1. So we're still isolating the variable when we multiply by the reciprocal. So now if you look at the right-hand side, the thing I want to do before I multiply the negative 6 by the 3 over 2 is to turn negative 6 into a fraction. So if I want to turn negative 6 into a fraction, I have to put it over 1. Then I can go ahead and do the same thing. So multiply across. Negative 6 times 3 is negative 18. 1 times 2 is 2. Negative 18 over 2 is negative 9. So 1x equals negative 9, or just x equals negative 9. If I went back and checked that, 2 times negative 9 over 3, that'd be negative 18 over 3, which is negative 6, which is what I wanted. Then we've got negative 3/4 x equals negative 2. Now what's different about this one and the last one is where our x is placed. So notice on the top equation, the x is right next to the 2. Now on this equation, the x is out to the right of our fraction. But really, I could rewrite this to look like the top equation, and I would still do the exact same thing. These two are the same. So the x can be placed in different spots, and your steps will still be the same for solving. So since I have a fraction, -3/4, the way I get rid of my fraction is by timesing by the reciprocal. Don't forget that negative. So 4 over -3 times -3/4 makes 1, cancels, so we don't need to write that. Now I need to turn my -2 into a fraction, so -2/1. So -2 times 4 is -8. 1 times -3 is -3. Now this one, there's a couple things. First of all, 8/3 doesn't divide nicely, so we can just leave it as a fraction, 8/3. The one thing I do have to change is that since I have a negative and a negative, 2 negatives make a positive. So technically the correct way to write this is not -8 over -3, but +8/3. Because a negative divided by a negative makes a positive. So +8/3 is my answer. Summary. To solve a one-step multiplication or division equation,